Hey guys, today we're going to talk about exponential growth, which is Module 13, Lesson 2 in your textbook. You can find math on the spot videos on your on the textbook website if you go find Module 13, Lesson 2, and they might supplement the videos we're going to talk about. So for our discussion, let's start with this function right here. F of x equals 2 raised to the power of x. So what we're going to do is we're going to call this one of our parent functions. Basically, these functions have lots of different parent functions, and it has to do with what this number is that's being raised to the power. So in this case, it's 2. So for this parent function, we want to draw a graph. So what I would suggest you do is make a little table of values, have some x and some y, and let's use 0 for x and 1 for y. So let's see, 2 raised to the power of 0, that is 1, and 2 raised to the power of 1 is 2. What is 2 raised to the power of 2? Well, that's going to be 4. And let's go the other way. What would 2 raised to the power of negative 1 be? Think back to before spring break. What do we do when we have an exponent that's negative? Well, we put it where it's not. So that would be 1/2. So that's going to give us 4 points that we can graph. We can plot those points, and then we should be able to get a pretty decent graph of our function. So I'm going to start with the first two I did, the 0, 1, and the 1, 2. And then when x was 2, y was 4. And then when x was negative 1, y was 1/2. So what does it look like that graph is doing? Go ahead and graph that on your graph y equals 2 to the x on your graphing device, whether that be your calculator that you downloaded, or maybe you're using Desmos. So pause the video and draw that graph. So hopefully when you graphed it, it looked something like that. Notice that that function has an asymptote. It has a horizontal asymptote. The horizontal asymptote is basically the x-axis. So I'm going to draw my asymptote here in just a second. So this horizontal asymptote might look something like that. So the horizontal asymptote is the x-axis, or y equals 0. Let's also talk about the domain and the range. So domain, that's going to be all real numbers, but let's reintroduce interval notation. So remember, all real numbers is from negative infinity to positive infinity. And the range is from the bottom of the graph to the top, and if it has a horizontal asymptote, then the bottom of the graph is 0, and it goes from 0 to infinity. Notice I used parentheses on all those because you cannot ever equal infinity, and the function never quite gets to 0. So when we're drawing these functions, we're going to refer to some reference points like we have with other functions, and I have those colored red. So the reference points for this function are the points, let's use red, 0, 1, and the other reference point is 1, 2. And I would just point out to you that this number, the 2, is always going to be this y-coordinate for the reference point. So 0, 1, every exponential function that hasn't been transformed starts with a reference point of 0, 1. and then the other reference point is always going to be 1, and then whatever this number is. Now that's when we haven't moved things left, right, up, or down, or stretched them like we will. So here's another parent function. This one is f of x equals 10 to the power of x. So take a moment and see if you can write down those reference points. So hopefully you wrote down 0, 1, and 1, 10, and if you type that into your graphing device, whether that be Desmos or your calculator, then you're going to see that this function is still a growth function, but it grows much faster than the one we had before. So the 0.110 won't show up on my current grid, but if I go right 1 and count up 10, that's where that point would be. What will be the domain and range of this function? Well, the domain is all real numbers, so negative infinity to infinity, and then the range will still be from 0 to infinity. This function also has a horizontal asymptote, and that horizontal asymptote is still y equals 0, also known as the x-axis. Now the next function that we're going to talk about is the kind of generic parent function, and that is f of x equals any number raised to the power of x. And that b there stands for the word base. So that is a different b than we've been talking about with our function transformation. So that's just some base raised to the power of x. And again, the reference points will be 0, 1, and 1, b. And if we can plot those 2 points and draw a curve, then we can graph any of these parent functions. So the next couple of things we're going to do is some transformations. So here's a little more complicated function. We've got 3 times 2 raised to the power of x minus 2, and then subtract 2. So it's been a little while since we've been face to face. It's been a little while since we've talked about function transformation, but see if you can figure out who a, h, and k are. So a is going to be 3, h is going to be our 2, and k is going to be our negative 2. So here's a, here's h, and here is k. So just like we've been doing all year long, we've got a, h, and k. Pause the video and see if you can write a description of this function. What do those transformations do? So hopefully you said something like, translate right 2 units, down 2 units, and vertical stretch by a factor of 3. And if it goes down 2 units, then what part of the function will that change? Well, that's right. That will change the horizontal asymptote, and it will also change the range. Now, the next thing I'm going to show you are a couple of formulas to get our new reference points. Now, those formulas look a little intimidating, but really they're just referencing everything we have up here. A, H, K, and the base for this one, which is B. So 0, 1 becomes H, comma, A plus K. Well, H is 2, and A plus K is 3 plus negative 2, which is 1. So that reference point would be H, which is 2, and A plus K, which is our 3 minus 2, 1. And then the 1 comma B translates into 1 plus H, comma, A times B plus K. So remember what H was. H was 2, and 1 plus 2 is 3. And then AB plus K. So we're going to take A, which is 3, multiply it by our b, which was 2. 3 times 2 is 6, and then we're supposed to add k to that, but k is negative 2, so 6 minus 2 is 4. So our reference points that we would plot on our paper are going to be 2, 1 and 3, 4. The horizontal asymptote, as we said earlier, is going to move down 2 units, so that'll be y equals negative 2. It's always going to be y equals k. And then our domain is still negative infinity to infinity, and our range is going to be from negative 2 to infinity. So domain, negative infinity to infinity, range will be negative 2 to infinity. So feel free to type that bad boy into your graphing device and see if you don't get those same reference points that we got and the same asymptote and domain and range that we got. So let's do one more in this video. So here's our newest function. Notice it's the same parent function. It's a base of 2, but see if you can find a, h, and k, and then see if you can use our formulas from the previous slide and find the reference points. Pause the video and try all that. So our a was negative 3, h also was negative 3, and our k is 4. K being 4 tells us that the horizontal asymptote will be y equals 4, because it's always y equals k. And then when we use our formulas that you wrote down on the previous screen for the reference points, 0, 1 should become negative 3, 1, and 1, b should become negative 2, negative 2. Let's draw a quick graph of that. So here is my y-axis, there is my x-axis. I'll just count up 1, 2, 3, 4. Here is my horizontal asymptote cleverly drawn in, and then when I plot those 2 points, the 2 reference points, negative 3, 1 and negative 2, negative 2. So our graph will look something like that. So strangely enough, this is still a growth function, but it's a growth function that's been reflected over the horizontal asymptote. So the transformations, we shifted left 3, up 4, reflected vertically, and then multiplied with a horizontal stretch factor of 3. Okay, so that is exponential growth. The next video you'll watch is going to be on exponential decay.